Page 4, number 17. The diagram below is of a square pyramid. Now, when they tell you a word before the word pyramid, they're telling you the shape of the base. So the fact that they said this was a square pyramid means that this bottom base for your pyramid has all the side lengths the same size. So I'm going to put a bunch of tick marks here to show that all 3 of these sides, or 4 of these sides, are all the same length. If the volume of the pyramid is 360 cubic feet, so they're telling us volume, 360 cubic feet. I'm going to put that below my pyramid to organize my information. And the length of one side of the base is 15 feet. So my base has one side is 15, but since we know that it's a square, that means all the sides have a length of 15. So I'm going to put 15 feet into my diagram, and I'll also put it here. Okay, what is the height? All right, here's my ask. What is the height? Now, the height of the pyramid goes from the top apex all the way down to your base. Now, a lot of times you see that drawn into the center of your base, and that's what I did here. I drew it to the center of the base. And I'm going to make it perpendicular because heights are always perpendicular. So they're asking you, what is the height? What is h? I'm going to label that h. Now, they gave you a volume and they're asking you for a length. Now, this is a working backwards problem. If they give you something like volume or surface area or circumference or perimeter, and they're asking you for one particular length that has to do with that shape, they're asking you to work backwards. So I'm going to write down that this is a working, let me zoom in a little bit here. This is a working backwards problem. Okay, working backwards. Now, the way that we work backwards for these problems, now that we've realized this is a working backwards problem, is we first have to take a look at what is the thing that they gave us that's already solved for us. Now, what they gave us that's already solved for us is the volume of 360. So what we're going to do is we're going to think, okay, well, how did they get to that volume? What's the formula that they would have used to get to that volume? So they would have used the formula V equals, since it has a point, it's 1/3 big B H. Now we already see the height is right here. That's what we would have to solve for. Now big B, as you remember, is not a single number. It hides a formula behind it. It hides the area formula for your base shape. Since they said it's a square and we saw our visual, it looks like a square. Okay, it looks like a square. We're going to replace big B with the area formula that big B is hiding. So I'm going to do a little arrow here. I'm going to draw a little square to remind me that it's a square. And I'm going to rewrite the rest of the formula. So V equals 1/3. I'm going to replace big B with the area of a square. Now, area of a square can be thought of as length times width, but since all the sides are the same, it's like a side length times itself. Sometimes you see it as S squared, but I'm going to keep it as length times width because I know that really is more familiar for most students. So length times width, and then I still need to bring down H for height. Now, once we have our formula written down that they would have used to get this 360, we're going to plug in everything that we know. Now, usually we don't plug anything in for the left side of the equation, but in this case, since we have the volume, they gave it to us, we're going to plug in for the V. We're also going to plug in for the length and the width of your square, but what we're going to do is we're going to leave H as our only variable in that equation, and we're going to solve for it. So let me go ahead and focus just on our work here. And now let me go ahead and plug in. So I have 360, which is your volume, equals 1/3. The length and the width is 15. So 15 times 15. And the height, well, that's what I'm solving for. So I'm going to leave that as h. Now, I can either multiply both sides by 3 in order to get rid of this denominator of 3, or I could just multiply straight across. So I'm just going to multiply the entire right side here. So I'm going to multiply 15 times 15 and then divide by 3 at the end. That's the same thing as multiplying by 1/3, is dividing by 3. So I'm going to go to my calculator, and I'm going to do 15 times 15, which you should know, it's 225. And then we're going to divide by 3 equals. So that's 75. So now I'm going to keep going. 360 equals 75 h. Now we're going to divide both sides by 75. This is all just algebra. And now in the calculator, 360 divided by 75 equals 4.8. That's your height. You've just worked backwards to solve for h, your variable for height. Let's go back to the top, put our answer in. Our answer is 4.8 feet. And we're done. Moving on. Number 18. The density of a gold necklace is 19.3 grams per centimeter cubed, and the mass is 192 grams. Before I move on, I'm going to go ahead and focus on the fact they're talking about density. You may have seen this in your science classes, but there is a special way of figuring out density that comes with a nice little graphic, and I'm going to draw that graphic for you. So it's called the density triangle. It looks like this. Anytime you do a density problem, if it's your typical density problem, you're going to draw a triangle, and you're going to split it into 2 parts, and then the bottom part you split into half again. Now you write it as D for density, M for mass, V for volume. Kind of like DMV, Department of Motor Vehicles, DMV. And this is going to help you figure out if you should multiply or if you should divide in your problem. So let's take a look at how we use this triangle and what the question is telling us. So our question says the density of the gold necklace is 19.3 grams per centimeters cubed. So grams divided by centimeters cubed. So this is one value right here. So I'm going to write down D equals 19.3 grams divided by centimeters cubed. Now that centimeters cubed should already tick me off to the fact that, okay, this is going to be volume, I think. I mean, centimeters cubed, units cubed, that's only for volume. What else did they give us? They said, and the mass is 192 grams. So I'm going to write down mass is 192 grams. The question is, the ask, what is the volume to the nearest hundredth? So you're going to round to the nearest hundredth, but you're looking for volume. So we're going to be looking for that centimeters cubed. That's what we're going to be looking for. Now, the way that you use your triangle is you think about which of these 3 letters am I solving for. In this case, we are solving for volume right here. So what you need to do is you need to take a look at the other 2 letters, the D and the M, the density and the mass, and you need to see how they're laid out. Right now, we see that mass is over density. That's telling you that you're going to divide. You're going to divide mass by density, and you'll get the volume. So we are going to do V equals M, the mass, divided by density. And that's how you use your triangle. So think about what is it that you are trying to solve for. And in this case, it was the V. And then think about, well, what are the 2 values that I have and how do they appear? So if M is on top of D, you're going to do mass divided by density. If you are trying to find mass and they gave you density and volume, well, those are next to each other. So you would multiply them together. Okay, and that's how you're going to use your triangle. So let's focus on what we're doing. We're trying to find volume. So we're going to plug in the values that we have. So volume equals, our mass, they told us, is 192 grams divided by our density, 19.3. I'm sorry, yes, 19.3. 19.3 grams per centimeter cubed. Now don't worry about the units, just focus on the numbers. We're dividing 192 by 19.3, and whatever we get, that is our volume in centimeters cubed, because volume is always cubed. So I'm going to go to my calculator, I'm going to type in 192 divided by 19.3, and I get this long decimal. And I go back to how they told me to round. They said round to the nearest hundredth. That means the second decimal place. So looking at your calculator, see where the 4 is? 9.94. You have to decide, do I keep the 4 or do I round up to 5? And the way that you decide is you look next door to your right. 8 is above 5. So it's going to tell you to round your 4 up 1 unit to 5. So our final answer is going to be 9.95 centimeters cubed. That's our volume. And that's how you use the density triangle. Let's go on to the next question. Number 19. Now there's a lot of really great things to talk about with this question, so let's get started. Mr. Brown's geometry class has 25 students. So there's 25 students in one class. After lunch, all 25 students return to class. Over the course of the next hour, each student produces 1,200 BTUs of heat. Now, you may have never heard of BTUs before, but it stands for British Thermal Unit. So they let out 1,200 BTUs of heat each for each student. Mr. Brown's classroom is 22.5 feet by 30.4 feet by 16 feet. How many BTUs per cubic foot were produced to the nearest whole number? So your ask is right here. How many BTUs per cubic foot were produced? Now they're definitely asking you in total. They said there are 25 students, they're all in class. So in total, how many BTUs per cubic foot were produced? Now you may have never heard of BTUs before, and you could still do this problem very easily. And that's by focusing on what they're asking you for in terms of the units that they're giving you. They're saying they want BTUs per cubic foot. That word per means you're going to divide. Per means divide. BTUs divided by cubic feet. Now think about it. What's a cubic foot? When do we use cubed units? We use that with volume. So they're saying take your BTUs, divide by the volume. The volume of what? Well, the volume of the classroom is the only thing that they gave you. So let's think about what the classroom looks like. Let's figure out how many total BTUs there were, and let's solve this problem. So for the classroom, I'm going to whip up my Van Gogh artistry skills here, and I'm going to draw a classroom. Now you should just know that if they're not really going to mention to you what type of shape this classroom is, you're probably going to have to assume that it's a rectangular prism. So here's my rectangle, here's my second rectangle overlapping, and here's the magic art trick. Connect all the corresponding vertices. And there we go. So this is a 3D model of Mr. Brown's classroom. 22.5 feet by 30.4 feet by 16 feet. 22.5 is the only thing that's written as a mixed number. Let's get them all into the same decimal format. So 22.5, a half is 0.5. So I'm going to write 22.5 feet for the length. The width, I'll put 30.4 feet. And then the height of the ceiling is 16 feet. Now, it doesn't really matter where all these measurements go, and we'll see why in a second. Now, my goal is to get BTUs per divided by cubic feet. So I'm going to start setting up what I need to do. I'm going to zoom in just a little bit here. Okay, so I need to do total BTUs, divided by volume. Now, for total BTUs, I have to remember there are 25 students. So I need to do 25 times however much one student produced in BTU. So 25 times one student. And then for the volume, well, if I have a rectangular prism, you know that anything that looks like a box is length times width times height. So this is my game plan. Now, 25 students, and each student, look back to the question, each student produced 1,200 BTUs of heat. So I'm going to do 25 times 1,200 BTUs. Because 25 kids, each one produced 1,200, divided by the volume. So in our shape, we have 22.5 for my length in feet times 30.4 in feet times 16 in feet. So it's good that all of the units are in feet. If they weren't, we would have had to do some extra work here. Let's go to our calculator. So now we have, for the top, the numerator, 25 times 1,200. That gives us 30,000 BTUs produced in total. So now we're going to write down 30,000 BTUs all over. Now we forgot the volume, our cubic feet. So back to the calculator. 22.5 times 30.4 times 16 equals 10,944 cubic feet of space are in Mr. Brown's classroom. Feet cubed. And now all we need to do is divide. So back to the calculator. 30,000 divided by 10,944 equals. That is how many BTUs per cubic foot were produced. Now let's take a look at how it said to round. It said to the nearest whole number. So 2.7, I'm going to look at the 7, and I'm going to look next, or rather, I'm going to look at the 2, that's the whole number, and you look next door at the 7, and the 7 says round 2 up 1. So it's going to be about 3 BTUs per cubic foot. So let's go back to my work here. And I'm going to write down that this is equal to approximately 3 BTUs per foot cubed. And that's our final answer. So you didn't have to know what a BTU was. You didn't have to know how to figure out BTUs per cubic foot. You could have gone to the question, looked at the units, and picked up on the fact that per means divide. And cubic feet means you have to do volume. And from there, come up with the answer. Let's move on to the next question. Number 20. Pyramid X and Y are similar. When you see that word similar, you need to think scale factor and you need to think proportions, proportions, proportions. So it's really important that you note that when you see the word similar, you think proportions. They are your best friend in solving similarity questions. Proportions, proportions, proportions. Now, proportion is two fractions that are set equal to each other. Let's keep going. The volume of pyramid X is 216 cubic feet. Okay, so now we're talking about volume and similarity. We're going to have to take some notes in a second. So pyramid X is 216 cubic feet in terms of its volume. I'm going to write that underneath pyramid X to start organizing my information. 216 feet cubed. And I like that the information they gave me in the diagram also is in feet. Okay, it says find the volume of pyramid Y. This is our ask. We need to figure out the volume of pyramid Y. Okay, now the key is to use proportions when you have similarity. But to use proportions, you have to use the correct scale factor. So scale factor is going to be your first fraction, but you have to pick the right one. So we're going to take a couple of notes here about scale factor and figuring out what the correct scale factor is for your problem. I'm going to zoom in, give myself some writing space. So here are your notes. When you are talking about length and you're trying to solve for a length, or when you're trying to solve for a perimeter, a missing perimeter, your scale factor, I'm going to call it A to B. Next, if we have area, if we're trying to figure out area, surface area or just a regular area of a two-dimensional shape, since area is always expressed as units squared, you can't use your scale factor A to B. You have to take A to B and you have to square it. So if you're looking for area, because it's in units squared, you have to square your scale factor. And lastly, volume, which is what this question is asking about. If you're asked to find a missing volume, volume is always units to the third power cubed. So you're going to have to take your scale factor, A to B, and you have to cube it. Take it to the third power. Now you have to select the correct scale factor as the first fraction you use in the proportion. Now one more note on scale factor. These are all examples of scale factor. Your scale factor you come up with by taking a pair of sides, any lengths that you're given, and simplifying them so they're in simplest form. So for example, if you had a scale factor of 5 to 10, I would tell you that's wrong. That's not in simplest form. You can divide 5 and 10 by 5 to simplify it to 1 to 2. So this would be a scale factor. 5 to 10 would not be. It would be a comparison of quantities, but it would not be your scale factor. So make sure you have scale factor in simplest form. Okay, we're going to be using this scale factor today for this question. Let me erase my not so good example and go back up to what we're going to do in this question. Okay, my goal is to set up a proportion. I've already decided that my scale factor is going to be cubed, but I first have to figure out the scale factor. So I am given, luckily, a pair of sides here. 8 compared to 12. They're both heights. Now I'm going to take those side lengths, or heights in this case, and I'm going to simplify them. So I'm going to write down 8 to 12. And I'm going to simplify that because that is not in simplest form, that ratio. You can divide both sides by 4. So I'm going to simplify it to be 2 to 3. This is my scale factor, A to B. Now we've already decided that our scale factor A to B has to be cubed because we're talking about volume. So let's go ahead and set up our scale factor and our proportion by taking this 2 to 3 and cubing it. So setting up my proportion, I'm going to take the 2 and the 3 and I'm going to cube them because I'm going to be solving for volume. Now, my volumes that I have are for pyramid X but not for pyramid Y. Now pyramid X has 216, which goes along with the 2. So I need to make sure I keep things matching. So I'm going to put 216 on the right side, up top, so that's matching up with the 2 up top. And now I'm going to try and solve for Y, which is my volume that's missing. Now, let me simplify this a little bit. 2 cubed means 2 times 2 times 2. 2 to the third power is 8. 3 to the third power is 27. You could use your calculators to figure that out, or you can use your minds. 216 over y. Now, to solve a proportion, you're going to cross multiply. So let's multiply 8 times y, and you get 8y. And now we're going to multiply 27 times 16. Let's use our calculator for that one. 27 times 216. And you get 5,832. Last step, divide by 8 so that you can get y by itself. Okay, dividing by 8. So in the calculator, divided by 8. And we get exactly 729. And remember, this is the volume, so it's going to be in feet cubed. This is going to be our final answer. So let's go to the top and let's write it in. 729 feet cubed. So remember, similarity, you're going to use proportions, proportions, proportions. Just make sure that when you decide on your scale factor, as you're setting up your proportion, you're using the correct scale factor. If you're just solving for a missing side length or a perimeter, then just use the regular scale factor. A pair of sides simplified gives you that regular scale factor. But if you're trying to solve for an area or a volume, is it going to be the squared or is it going to be the cubed? You have to think, what am I solving for? I have to use the appropriate scale factor in my proportion. All right, let's move on. For number 21, there are 3 different problems that you have to solve. It says solve for the variable in each diagram and round to the nearest hundredth if necessary. Now, all 3 of these diagrams are related. They picture the same type of thing. What you should see is that there's 3 right triangles, and for each of them, the right triangle is going to have a length, an altitude actually, coming off of the right angle, perpendicular to your hypotenuse. So it goes off of the right angle, perpendicular to the hypotenuse. In the middle one, same thing, coming off the right angle, perpendicular to the hypotenuse. And in the last one, coming off of the right angle, perpendicular to the hypotenuse. These are going to be problems that test the mean proportional theorem. And I'm going to talk to you about the mean proportional theorem in my own little unique way that I came up with. So if you don't like it, stick to the way that your teacher taught you. I'm going to start with the one all the way on the right. Now there's one of 2 different formulas that you're going to be using. Both of them are proportions. There is one known as the altitude rule and one known as the leg rule. Now looking at the diagram all the way to the right, if they give you information for the altitude, or they ask you to solve for it, which in this case they're asking you to solve for it, you're going to use the altitude rule. So again, if they give you information about the altitude, or they ask you to solve for it, you're going to use the altitude rule. And the altitude rule looks like this. I call it, and I'm going to zoom in so we can just focus on this one problem right here. I call it short over alt, in other words, altitude, equals alt over long. So short over alt equals alt over long. Now, what does that mean? That means the short part of your hypotenuse, because as you can see, the altitude cuts it into 2 parts, the 7 and the 18. So the short part over the altitude, which is your x, equals the altitude over the long part. Now you'll notice, because this is a proportion, the short and the long are going to end up multiplying together. So it doesn't really matter if you put the short as the long or the long as the short. If you mix the 2 up, it's okay. But the key is that you have the altitudes right here as your other diagonal. Now, let's go ahead and plug in. So, my short is the 7. The altitude is x. Altitude is x. And the longer part of the hypotenuse is 18. We're going to go ahead and cross multiply. So 7 times 18. In my calculator, 7 times 18 equals 126. 126 equals x times x, which is x squared. I don't want x squared, I just want x. So I have to square root at the end. Take the square root of both sides. And now I'm left with x is approximately equal to, let's see in the calculator, square root the 126, 11.22, yada, yada, yada. So we need to round to the nearest hundredth. So I'm looking at that second 2, and I have to decide, do I keep it as 2 or do I round up? When I look next door at the 4, it's not above 5. So that means I'm going to keep the 2 where it is. I'm not going to round up. So my answer is 11.22. And that's the length of x. Let's try out 2 other problems. So now looking at the other 2 problems, okay, the first one, you notice, well, there's no information for this altitude. There's none, and they're not asking you to solve for it. So most likely, you're not going to use the altitude rule that we just talked about. For the middle one, notice that yes, they give you an altitude. They give you information for it. So I'm probably going to have to use the altitude rule. So let's do that middle one first. Zooming in. Again, remember, it's short over alt equals alt over long. Now, my short piece is 5. That's what it looks like. It looks like it's a shorter piece. 5 over my altitude, which is the 7, equals 7. It's the same number. It always repeats. Over the longer piece. Now, the longer piece is right here. That's the longer piece of the hypotenuse. That x is not actually that longer piece. That x is the whole hypotenuse. So to get that longer piece, I have to set up an expression. I'm going to take x and I'm going to subtract 5. I'm going to call it x minus 5. Because imagine if this x was actually, I don't know, let's say it was 9, for example. Then if I asked you, well, what's this longer piece on the left? You would say, well, subtract 5. 9 minus 5, and you would tell me that longer piece is 4. But in this case, we don't have something for x. It's just x. So you're going to think, well, x minus 5, whatever x is, would give me that longer piece. So I'm going to call the long piece x minus 5 and keep it as an expression. And then again, just cross multiply to solve. So I'm going to do 5 times x minus 5. 5 parentheses x minus 5. Keep that x minus 5 denominator protected. You have to multiply the 5 by both terms, the x and the negative 5. For your other diagonal, 7 times 7 is 49. Now you have a choice. You can distribute the 5 to both terms, or one of the tricks I like to do is I like to divide both sides by 5 right away to get rid of this 5 in front of the parentheses. I'll go ahead and distribute because I think that's what most people are used to. So let me go ahead and distribute. 5 times x is 5x. 5 times negative 5 is negative 25. Equals 49. Next, I'm going to add 25 to both sides. Those cancel. Now I'm going to have 5x equals, let me go to my calculator, 49 plus 25 equals 74. And lastly, I'm going to divide by 5. So I have x equals 14.8. No need to round. It said round when necessary. If you want, you could throw a 0 on there to show that it is rounded to the nearest hundredth. Okay, last question. Now, I mentioned to you that, well, this one doesn't ask you for the altitude, so you're not going to use the altitude rule. The other rule is known as the leg rule, and it goes like this. It's whole over leg equals leg over part. Now, whole stands for the whole hypotenuse. So in this example, our whole hypotenuse, well, it's split up into two parts. It's 15 and y. So the whole hypotenuse would be y plus the 15. That's going to be the whole hypotenuse. And then the leg is one of the two legs that makes up the right angle at the top here. So the leg that they gave us is the 32. So I'm going to use the 32 as my leg. Then you repeat that leg again, 32, and then it says part. Part means the part of the hypotenuse that's touching your leg. 15 is touching the leg that's 32. Y is not. So I need to use the 15 if I'm going to use a leg that's 32. So let's go ahead and put that into my proportion that we've talked a little bit about it. So whole hypotenuse is y plus 15 all over the leg that they gave us, 32, equals the leg that they gave us, 32, over the part of the hypotenuse touching your leg, which is the 15. Let's go ahead and cross multiply and solve. So 32 times 32 in my calculator, 32 times 32, or 32 squared, would be 1,024 equals 15 times the y plus 15. I'm going to do 15 parentheses y plus 15. Now again, you can distribute the 15. I'm not going to do that. I'm going to use the other little trick that I do, which is I'm going to get rid of the 15 by dividing both sides by 15. This will cause the 15s to cancel out on the right and free up the parentheses. So now I'm going to be left with 1,024 divided by 15 in the calculator. Divided by 15. I get 68.26 repeating. And that's not such a great number, but I'm going to write it down. 62, oh, not 16. 62 point, oh, keep writing the wrong thing. 68.26 repeating equals, and now I've freed up the parentheses, so y plus 15. I'm going to subtract 15, and luckily it's still in my calculator. So minus 15 equals, so my final answer is going to be 53.26 repeating, but I'm going to round to the nearest hundredth. So it's going to be 53.27 equals y. And that's my final answer for y. That completes page 4. Let's keep it moving.